Hello, welcome to another video of heuristic algorithms. In this video I'm going to demonstrate the nature of some of the combinatorial problems that we can solve and how we can use some algorithms to try to solve it. In this problem what we have is a scheduling problem with 2 stations and we have 15 jobs. The main task is to define the sequence in which we're going to start each one of the projects, each one of the jobs through the job shop. All of the items follow the same path. They go first through a first station and then a second station. Each one of the jobs have different times. So let's say, for instance, this first column indicates the first job to be processed. The job ID is 6. We're going to come back to a random number later. The job ID is job ID number 6. The due date is 137 times units in the future, and the process time in the first station is 9 units of time. The processing time in the second station is 9 units of time, and we can compute that for the first job in the sequence, the starting time will always be 0. Therefore, the finishing time in the first station is going to be 0 plus the processing time in the first station, which is 9 units, and the starting time in the second station is it will start as soon as we finish in the first station, and therefore we start at time 9. The process time 2 is also 9, so we finish that job at the unit of time number 18. In the meantime, we have a second job waiting, and as soon as we have it available, that means that we can the job ID 13, as soon as we have it available, we will start a process. The due date is 7 units from now. The process time in the first station is 8 units. The process time in the second station is 12 units, and as soon as we have available the first station, we can start the work on this one. So the previous job finished at t equals 9 in the first station. So this second job, in terms of order, the job ID 13, we can start at t equals 9, and since we have 8 units of processing time, we will finish that job at t equals 17. This job is going to continue to station number 2 as soon as both the maximum of either the previous job in the station 2 has finished, or this job in station 1 has finished. So the latest of the 2 events are going to determine when we can start this job in the second station. As we can see, the second job in the first station finished at 17. The first job in the second station ended at 18, so we can start this job at 18. The process time is 12, so the finishing time at station 2 is 30 units of time, and we do that process for all of these 15 jobs that we have. Once we have that, we can compute the lateness of the job. That is, comparing these finishing times to the due date. If the finishing time is earlier than the due date, that means that there is no lateness, and we can use 0, and we can assign a tag of that this is not a late job. In considering the opposite situation, if the finishing time is more than the due date, is larger than the due date, then that means that the difference between those two times is, in this case, 24 for the third job, job ID 11. That means that that this job is late by 24 units of time, and we can assign a tag of 1 because they're in the column of late job. And we have, if we produce these jobs in this particular sequence, that is first job ID 6, and then job ID 13, and then job ID 11, and then job ID 1, and so on and so forth, the 15 of all of them, we will have 422 units of lateness, and we will have 13 out of 15 jobs late. So we can try to develop some kind of heuristic algorithm about this. One that comes into mind is, well, why don't we sort these jobs based on the due date in such a way that those that are more urgent, we try to process them earlier and see what happens if we can get rid of both the lateness and the fact that the job was late. So for that, all I need to do is do a custom sort in Excel, and I'm going to sort these works based on due date from the smallest to the largest. And if I do that, something interesting happens, is that now all the jobs are late, but the number of the total lateness diminishes from 122 to 259. So while every customer will feel that the job was late, at least the overall experience for everyone is not being as late as some of the previous cases in which some of the customers really have to wait a lot longer. So those are the trade-offs that we will have in practical cases in the type of problems that we want to solve with our algorithms. Now, this is a very simple algorithm, but that doesn't guarantee that this is the best solution to either minimize the total number of hours or the total lateness or the late job. We would like to explore some other alternatives, and an easy way to do it is, well, we could just try randomizing the order that we have. For that, I have created this column, and if I sort based on that random number, then the whole set of the sequence is going to change, and that will give me an alternative solution. So now I'm going to sort based on the random number, and interestingly, as I sort based on these random numbers, the random numbers are recalculated, so I'm ready to resort again. So that's why you don't see this column of random numbers strictly sorted in the proper way. But anyways, this is just an alternative solution. Notice that remarkably we have less number of late jobs, but now we have even more lateness, total lateness in our case. We found 524. We can try this again. I don't know what happened. Let's see. I'm trying to sort the whole thing now. I need to be careful there. It's just sorting the columns that do not contain the formulas that compute when every job is starting, when every job is finishing. And I sort again, and there we go. Now we have only 10 jobs late, but it's 499. Now this process, as it is, if we just generate random numbers, is like trying to win the lottery. We are not actually executing a very smart algorithm. Smarter algorithms try to learn somehow from the previous solution, or at least try to improve from the previous solution. In this case, if we just randomize, we will not necessarily improve. So one way to improve is to, from the current solution, explore a neighborhood and figure out if we can obtain a better solution given the current solution that we have. Alternative, we can compute this problem as a linear programming, mixed integer programming problem, and try to solve it using Microsoft Excel solver. And those are going to be two tasks that we're going to tackle in this course.